this question comes from Majezu. I hope I pronounced that right. Thanks for sending in your question. So we've had Stephen, we've had Tumi, Majezu. Here we go. Alrighty. If we look at this, it says the diagram below shows a side view of the male reproductive system. People, you know what? There are always so many questions on the female reproductive system, and the guys tend to, or you, not guys, the guys and the girls tend to forget to learn the male reproductive system. It's not very complicated. I mean, it's not nearly as complicated as the female reproductive system because, well, males just make sperm and deposit. Females have to carry that baby, so it's a lot more complex of a system. And I'm not being feminist when I say that either. It is just the way things are. Alrighty, so the diagram below, the first rule is always to write in your label. So your label here, that would be a testis. Okay, that testis means that there is one of them. When there are two, then we say that they are the testes. All right, so just remember, if it's IS, there's only one, and if it's ES, then there are two. Okay, it says explain why structure A, which is the testis, or testes, is situated outside of the body. Well, that's easy. It's because the optimum temperature for sperm production is 35 degrees Celsius. So the reason the testes are outside or located outside the body in the scrotum is so that the temperature, a lower temperature, can be maintained because 35 degrees Celsius is the optimum temperature for sperm production. Okay, so I'm going to put here just so that you remember 35 degrees C, because it's lower than body. For optimum sperm cell production. Okay, I wasn't going to write all of that, but now I have. Okay, so it says give two functions of the hormone produced by structure A. So structure A are your testes, and what hormone do they produce? Come on, guys, you must know this. Okay? The hormone is going to be testosterone. Okay? This hasn't been asked in their question. I'm just giving you this. So the hormone that's produced, so testosterone, produced by the testes, okay, in the, let's get all the details here, in the seminiferous tubules, okay, and by the Leydig cells. So the Leydig cells are in the seminiferous tubules, and which are in the testes, and it's those Leydig cells in the seminiferous tubules inside the testes that produces the hormone testosterone. Now the question was to, let me just go back here. The question was two functions. So what are and there are only two functions. So what are the functions of testosterone? Okay, it's going to be function number one is, and this is very important, the development of secondary sexual characteristics. Now remember, what have guys got that girls don't have? Guys have an Adam's apple, they are hairier, they got hair on their face, you've got hair around the genitals, under the arms, more muscular. All of those are your secondary sexual characteristics, and that is because of testosterone. The second function of testosterone is that it stimulates the development and maturing of sperm cells. Because remember, the sperm cells are also produced in the seminiferous tubules, all right? I'm sure I've spelled it right. It doesn't look right, but if I haven't, seminiferous, I can't think whether I've spelled it right or wrong. I've just gone blank. Alrighty, now let's go to our next question. And okay, so we've done that one and we've done this one. So the diagram below shows a human sperm and ovum. The diagram is not drawn to scale. Well, we all know that. I mean, you just have to look at this. The ovum, you're going to have your little sperm cells are going to be like this. So it's definitely not drawn to scale. Now it says tabulate one difference between the structure of the ovum and the structure of the sperm cell. People, when they tell you to tabulate, you must draw a table. Okay? So, this is question, what was it? Question 2.1, I don't know, I can't remember. But anyway, so now we're going to tabulate. So we draw our table. Okay? And remember, you get marks for drawing this table and putting the headings in. So you're going to put sperm cell. Okay? It's not just a sperm, it's a sperm cell. So it's a sperm cell and an ovum. You can also call an ovum an egg cell. But since the question talks about an ovum, just put ovum. But an ovum and an egg cell are the same thing. All right, so first thing, if we go back to this drawing, what do we see? Well, the egg cell is huge and the sperm cell is small. You've got a round structure and you have a head and a middle region and a tail. So those are two very obvious ones already. Okay, so the sperm cell is going to be small. It is small. And the egg is going to be large. Okay, or larger. The sperm cell has a head, mid region or area, and a tail. Whereas the ovum is round. Okay, the sperm cell, I'm trying to think what else has it got. I can think of ovum. The ovum has a jelly coating, whereas the sperm cell has no jelly coating. Okay, and that's about, okay, and obviously the sperm cell has the a nucleus with genetic material from father, and this will have the nucleus will have genetic material from mother. But I mean, all of this is very complex. The one is small and the other one is large. This one's got a head, a mid-region, and a tail, and this one is just one round structure. I mean, look at what is on the diagram and use that. It's not too easy. That's it. Simple. Okay. I mean, don't think of it as being too easy. So that one was an easy one. Then, the head of the sperm contains a protein digesting enzyme. Explain the importance of this enzyme during fertilization, guys. Now, in the front here, if you've learned your diagram of the sperm cell, is something called an acrosome. And that acrosome is where these enzymes are. So what you are going to say to answer that question, so for question 2.2, you're going to say the enzyme breaks down the outer jelly-like coat around the egg, or the ovum, so that the sperm cell head can penetrate the ovum and nuclei, that's the plural of nucleus, nuclei can fuse. Because what is fertilization? It's the fusion of the nuclei. So the enzyme breaks down this outer coat, the outer jelly-like coat. It breaks down this outer jelly-like coat that's around the egg cell so that this little sperm cell can go into there, and you're going to have this nucleus and that nucleus, and they join, and we have happy fertilization. Okay, now we go to the next question, and it says, an active, healthy sperm cell, okay, is able to swim 4 millimeters per minute. All right, now a millimeter is tiny. I mean, a millimeter is so much, and it can do that in 1 minute. So I know I have through the years had learners that think sperm cells like go shh, and they just fly. They don't. They have their little things. They're tiny, tiny little things, and they have to wiggle, 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 and swim their way through. So 4 millimeters a minute is actually very, very fast. So if the distance from the cervix to the end of the fallopian tube, okay, so you've got the vagina, okay, and then you've got the cervix here, okay, and from the cervix you go into the uterus, and then from the uterus into the fallopian tubes. Okay, so your little sperm cell has to go diggy, 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 diggy. So it gets put in about round, no, what am I doing? It gets put in about here. So there's the vagina. So when the male ejaculates, the little sperm cells are here. So so they've got to now swim up here, and then you'll have some that will go this way and some will go that way. These are your fallopian tubes. Okay, so fertilization takes place in the fallopian tubes. So they're saying this little guy, this healthy little sperm, is going to swim 4 millimeters per minute. And from the cervix to the end of the fallopian tube, which is where the egg is going to be sitting here waiting, all right? One egg, either this side or you're going to have one on that side, okay? That is 20 centimeters. That's quite a long way, guys. How long will it take for the sperm cell to reach the ovum at the end of the fallopian tube? Show you're working. All right, so let's see here. Okay, what are we going to have? We've got, it travels 4 millimeters per minute, okay? We've got the distance to the fallopian tubes is 20 centimeters. So you say 20 centimeters is equal to 200 millimeters, because we have to now convert to the same unit, all right? So we've got 4 millimeters and 200 millimeters. So what's next? We're going to say we've got 200 millimeters is the distance this little guy's got to travel, that little sperm cell's got to travel, okay? And he travels at 4 millimeters per second. So that means that it's going to take about, so 4 divided by 200, I mean, I don't need a calculator, is going to be 50. Therefore, it will take 50 minutes. Okay, because remember it goes 4 millimeters per minute. Okay, so 4 divided by 200 gives you 50. It's going to be 50 minutes for this little sperm cell to swim all the way to the ovum where it's going to fertilize that little egg cell, okay, or ovum. Okay, semen, let's do a different color. Semen has a pH of 7.5. That means that it is going to be slightly alkaline. Okay, slightly alkaline. Sperm cells have a high mortality rate. So what does mortality rate mean? That means dying. So it has a high death rate. Okay, so mortality rate is your death rate. In acidic conditions, so little sperm cells don't like acid. They like alkaline, not acid. But there are a lot of places that they're going to find acid. So how does the male body ensure that that little sperm cell, or the sperm cells, are not killed in acidic urine as they travel through the urethra? Now, guys and girls, okay, oh, I think guys will remember this. Girls may not, okay, is that males ejaculate through the urethra and they urinate through the urethra. So you're going to, the possibility is that there'll be a urine residue in the urethra if a male has urinated at any time before ejaculation. So we need to make sure that there is going to be no acidic residue there, and this is how it will happen. The urethra is cleared of acidic urine, or you can say acidic residue, okay, or any urine that's sitting inside the urethra. It doesn't matter how you want to say it, but as long as you say that, by secretions of the Cowper's gland, and it's belonging to, so there's an apostrophe S, Cowper's gland, before ejaculation. So it doesn't matter how you want to word it. At the end of the day, that urethra's got acid in it. We have to neutralize it. The neutralizing of the urea in the urethra, or the urine residue in the urethra, is going to be from the secretions of the Cowper's gland. Okay, look here. Let's get another color. I want you to, we've got the Cowper's gland. Okay, and we've already established that the Cowper's gland neutralizes urine residues. Okay, so it's got to be alkaline and assists with sperm cell motility. So in other words, it's going to help the little sperm cells swim faster, okay? Or just swim, basically. Right. Your next gland that's very important is your prostate. Prostate gland. And what does the prostate gland do? Well, it neutralizes acid in the vagina. Okay? And by neutralizing that acid in the vagina, why? Because it is alkaline. Okay? And it also assists with sperm cell motility. In other words, the swimming ability of the sperm cell. And a third structure that adds to the semen is your seminal vesicle. Okay, and the seminal vesicle, okay, also release an alkaline fluid. This is very watery. So it's an alkaline fluid to increase motility. And it contains fructose to provide energy for sperm cells. Okay, so that they can swim. So they need energy, and that energy comes from your seminal vesicles, that fluid. It's a whitish milky fluid. All right, so when we take all three of these, so the fluids from all three of these, okay, plus, okay, so we're going to do fluid plus sperm cells, that gives us semen. Okay, and that semen is what is ejaculated. But before anything happens, little bit of fluid, when the male is aroused, little bit of fluid will be coming from the Cowper's gland, and that Cowper's gland fluid specifically is to neutralize acid residue in the urethra of the male before ejaculation occurs, because you don't want to hurt those little sperm cells. Okay, you want the little sperm cells to be okay. All right, people, that's it for today. Thanks for sending in your questions.